Hey everybody, today we're going to work through congruent triangles, lesson number 3. And I'm pretty much doing about the worst thing a teacher could ever do. I am starting a lesson with a proof. So I apologize, kind of, I guess. We don't really have much of a choice, though. I want people to see exactly why we have to do what we're doing. So we're going to start the lesson with a proof. That means we're going to get a couple columns. We're going to do a 2-column proof here with statements and reasons. And you'll see, again, why I'm doing this here a little bit later. But for now, yeah, I know it seems really frustrating that we're going to start with a proof. So anyway, here goes. We've got our given things. And remember, whenever you have given things, you should just use them right away. And then when you need a reason, you can basically just say given, and then you don't have to worry about it. That looks good to me. Now, what I'm looking to do here with our triangles, we have been working on proofs. We have been working on how can I prove that this triangle is exactly the same as this triangle. And they are the same, and we're going to get through it. We have two things that we already knew. We already knew that AB was congruent to DE. That was right here, and that was right here. It is listed in our statements already. And we also have B and E are congruent angles. So that means this and this. They are actually marked as right angles, but that doesn't really matter. All we really need to know is they are congruent. That is not enough information yet. Remember, we have different ways that we can prove triangles are congruent. I mean, if you look at our list, we have side, 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 angle, side, angle, side, angle, and angle, angle, side. So we have to use one of those 4 things right now. The fourth one is going to be the one we use, and let me show you why. We actually have another set of matching angles, and that's going to be the ones here and here. Now, I'm going to name them, and you have to be specific with your name, and you have to say angle, and I'm going to go ACB here, because if you are to follow along, you would go from A to C to B if you wanted to make that angle, and it is going to be congruent to angle DCE. All right, and I know that's true because both of them happen to be vertical angles. So we are going to use the vertical angles theorem. Now, if you look, we have 2 matching angles on each triangle, and we have a matching side. The reason I am going to choose angle-angle-side here is because the side is not included. Angle-side-angle would look something like this, where the side would be in between the 2 marked angles. That is not what we have here. In this particular example, the side that is given to us is not included. It is not in between the 2 angles. Therefore, instead of using ASA, angle-side-angle, we are going to use angle-angle-side. So I am going to make my triangle statement here, and I am going to say triangle ACB. And you could have named it anything. You could have named it ABC in this case. The key to naming triangles has a lot more to do with making sure that both of your statements match than it does anything else. So triangle ACB is congruent to triangle DCE. That's what I chose. You could have gone differently. And we already talked about it. The reason is going to be the angle-angle-side theorem. Now, I don't know if you noticed, but that wasn't actually what they were trying to prove. What they were trying to prove was that segment AC was congruent to segment DC. So at this point, you might be looking and you might wonder, why did we bother with the triangle thing if the triangle thing was not what we were trying to prove in the first place? And so I just want to show you real quick why we're doing it this way. Now that we know that the 2 triangles are congruent, that means by rule every other thing has to be congruent too. Congruent triangles have 3 matching sides, 3 congruent sides, and also 3 congruent angles. So if we already know that the triangles are congruent, then that means everything else is automatic. This is congruent to this. It's automatic. This is congruent to this. Again, it's automatic. This is congruent to this. They have to be. As soon as you know that 2 triangles are congruent, every other matching part will be congruent to every matching part of the second triangle. So you could just go through and you could just say, well, they have to be. Okay, well, you can't say that. We actually have a name for this. It's going to be kind of long. I'm going to have you write it once, and then I'm not going to have you write it again. Corresponding parts of congruent triangles are congruent. Now, that's kind of wordy. I get it. It may take you a second to write it down, and that's okay with me. Corresponding parts of congruent triangles are congruent. Now, I'm going to tell you right now, what you just wrote is not actually a theorem. It's not a postulate. I thought it was interesting. The book referred to it as an essential understanding. Now, that doesn't necessarily mean anything. I mean, the word essential means you have to know it. And in this case, I would agree with that. If you don't know it, your proofs will not work. But again, don't worry about this phrase. Don't think you have to memorize this phrase. My point is, it's not a theorem, it's not a postulate, it's not a property, it's just something you need to know. It is essential for you to understand what we just wrote. And I get that it was wordy, which is why people in the geometry world have decided we should just abbreviate. If you take all the capital letters that I just wrote, you get CPCTC. That is a pretty much common knowledge abbreviation. It's something that geometry people around the world, or at least around this country, will recognize. Okay. So let's practice a little bit of how this would be used. Use the mark diagram to state the method used to prove that the triangles are congruent, and then name all of the other corresponding parts that we could then match up. Okay, that's what we're going to do. So I see a shared side, and whenever there is a shared side, you automatically can say that it is congruent to itself. Okay, so AY is congruent to YA, or whatever you want to say there. Okay. Now that we know these 2 triangles are congruent, and by the way, there is a method that we could use to know that these 2 triangles are congruent. Based on the picture, I see a side, and then I see an angle, and then I see another side. So first off, we should probably get this out of our system. The way that we know these 2 triangles are congruent is the side-angle-side postulate. Okay. The directions say, as soon as you figure that out, what else has to be congruent? And remember what we talked about before. Once we know that the 2 triangles are congruent, once we have a reason why the triangles are congruent, we can then just start matching up whatever we want. We can start matching up this with this. We could start matching up this with this. We could start matching up this with this. So, long story short, as soon as you have proven that 2 triangles are congruent, you can then do anything else that matches in the triangle as well. So let's mark this down here. The first thing we came up with were those 2 sides. So I could say segment DY is congruent to segment BA. That statement is also true. We tried this angle out. Okay, we should probably go with that. We'll say angle DYA is congruent to angle Sitting on the dock of the bay. It's a good song. There you go. DYA is congruent to BAY. All right. Then we also have this angle up here, and I get to be lazy on this angle up here. I can just say angle D is congruent to angle B. I don't have to elaborate because that is the only angle coming from point D. That is the only angle coming from point B, which means I can stop right there. All right. Let's try a couple more here. I'm going to slide over to the next example. It looks to me, before I do anything else, it looks to me like what I have here is the Angle-Side-Angle Postulate, because I have two angles and then the side that I am using is in between. Okay. So to figure out what else matches, I can match this angle and this angle. And again, as soon as I have proven that the two triangles are congruent, I can match whatever else I want. I can say this is going to match with this, and I can say this is going to match with this. So I shouldn't say whatever I want. I'm just trying to make the point that there will be some matching going on. All right, so now let's just name what just happened here. What else happened? Well, I said that angle T was congruent to angle V. That's good. Segment TU is congruent to segment VU. And then if you go across that diagonal, you could say segment TA is congruent to segment VA. All of those statements are also true. All right, now for the last example in this section, it's kind of hard to read here, so I want to make sure that we understand exactly what's going on. What you've got here is essentially the blue triangle and the green triangle. Those are the ones that we are trying to use. I can prove that they are congruent first and foremost using the Angle-Angle-Side Theorem because we have a matching angle up top. We have a matching right angle right here. And then the bottom sides match, not necessarily in the way you would expect, but we have a matching part and a shared part. And essentially 1 plus 2 equals 1 plus 2. I mean, I'm not going to get into the details of that particular thing right this second. I just want to show you where I got that logic from. So let's fill in the other details. So we have everything else that does match we can now name because we know that the triangles are congruent now. So I can say that and that. I can say that and that. And I can say that and that. So let's just give. If we go piece by piece, we can now say that Kn is congruent to Mt. We can say that Kh is congruent to Mg. And then we could do angles for our last one, and we could say angle KHN, that would be this one right here, would be congruent to angle MGT. All right, I'm going to zoom out. You can see all three of these, and we will we'll go through and we will do one last proof. Okay, so just a second of that. Pause it if you need to. We're going to do a proof really quick. So, complete the proof. And we are going to use everything that we just learned about matching up corresponding parts. Now, I'm going to give you a little spoiler alert right here. This line in the middle of the paper does not do you any good, so we're going to go without it. All right, so we've got a couple of things that were given to us, so we should probably do that. We also have xz is congruent to xc. We have that right in the middle. xc is congruent to xc. Yes, you are congruent to yourself. That is called the reflexive property. So that's a good one to throw in there. So now let's get into everything else. How do I know that angle yxz is congruent to angle wxz? The key here is in the word bisect. When you bisect something, you cut it in half. Bisecting does to angles what midpoints do to sides. Whenever you have the midpoint of a segment, you break the segment up into two equal pieces. The same thing happens with bisecting. If you bisect an angle, you create two equal angles. So when we need a reason for step 3, we don't have a great one, but we could basically just say that's the definition of bisecting. That's really all you need to do there. We have used that phrase for a couple different things. We've said definition of perpendicular. We've said definition of midpoint. Now we're going to say definition of bisecting, because it is way faster than trying to explain to somebody what bisecting does to angles. You can just say, well, it's the definition of bisecting. Now, if I look at this picture, it looks to me like what I have now is a side-angle-side situation. Now, the last step. How can I justify that YZ is congruent to WZ? Well, now that I have already proven that the two triangles are congruent, I can match up any other parts that I want that are corresponding just by saying corresponding parts of congruent triangles are congruent, aka our rule CPCTC. So that's what it's going to look like in a proof. Usually CPCTC will come at the end of a proof when you're trying to wrap up and match up two sides. So your goal is going to be to first prove the two triangles are congruent, and as soon as you do that, you can match up any sides or any angles you want that are corresponding just by using CPCTC. All right, thanks a lot. I'll see you next time.